Uh, Hi everybody, this is Subra. I am from the DKube team. So let me. So I'm a senior architect at One Convergence. Just to give you a brief introduction about DKube, Ajay in the morning already briefly touched upon the DKube, the functionalities. It's an MLOps platform. Are you guys able to hear me still? Hello?
We can hear you.
Okay, yeah. So it's an MLOps platform. It has both Kubeflow and MLflow. At the core, we use Kubeflow, and then so we integrate MLflow tracking. And then we implemented model monitoring. So that's the one that I'm going to talk about today. So we like to contribute to the community as another Kubeflow project, and that's something that we can discuss. Let me do a slideshow. Okay. What I like to do is I'll give you a little bit of a terminology of the concepts after monitoring without going too much into how we implemented a DKube. I'll talk about the features, and then we'll talk about the architecture, how we're going to implement it in the community, or how it's working for us in DKube. And then if there is time at the end, I'll give a lightning demo of the DKube, which is I'll do a live demo. So we're all familiar with the model lifecycle. So we have some training data, we create a model, we deploy it, and then so there is going to be a change in the data. So we do need to capture the inference logs, and then run some utility called a label studio. It's an open source utility. Create the labels and then retrain it. So the picture basically emphasizes that we need to have a feedback loop by monitoring the deployment, getting the logs, and then making a decision whether to retrain or not. Right. Some introduction into concepts. So why do we need a monitor? So we need monitor because the data is drifting. So if you think about what data is drifting, so you might have, so over a period of time, the features change, and then the type or the format or the integrity of a feature changes from, let's say, an integer to a string or something else. And also, your training data may no longer be relevant altogether. So, for example, you might have trained on one particular sample of population, and then you go, you deploy it somewhere else, and suddenly a lot of things like a race has changed, the population, a lot of things about the population that could change. So, because of this, your model drift. Model may not be predicting the way you would want to predict. So there's a drift in the prediction because there is a drift in the data. And then, so there is also a concept drift. Basically, that gives you a relationship between the input data and then prediction. So this is, for example, if you take the example for a model for a product recommendation system. Something like when there is COVID, your recommendation system suddenly would need to change to now recommend something else. It could be like a sudden change, like in the kind of in the case of an epidemic, or it could be a seasonal change. So, for example, on a Christmas Eve, you would want to do a recommendation something else, and then or it could be a gradual change. So you would need to basically measure, compute the drift on the input data, as well as once you have the label data, you would also need to be able to predict the performance degradation, right, based on the model type. Okay. And then these are some advanced concepts. It may not be anything to do with monitoring itself, but this is with respect to the operation of a model or a deployment, right? So explainability is one. So where you would want to basically understand why a model predicted in a particular way. so these are based on like feature scores. And also, so this also helps you debug your model. So you may want to say which features are getting more importance. And then there are a couple of other topics like outlier detection or anomaly detection, where so you would want to identify individual objects that are unusual in the input. So at a very very naive example would be like you're expecting all squares, and then you would see a circle. So that's like an outlier. So this is what is used in the intrusion detection at the network security level. And then there are other types of attacks that you may want to use to harden your model. So these are like adversarial attacks, some deceptive data causing your model not to behave correctly. So I think what we are going to focus on is the data drift, not so much on the explainability, at least to begin with, in the product that we are going to propose. And then I think if there is enough interest, we could also get into these concepts as well. But some of it, I think if you see KSER, I think some of it is implemented in some fashion in KSER. I think it requires having some discussion with other project to see what makes sense. Right. So in terms of features, a quick time check. Okay. In terms of features, the drift detection, the model monitoring need to be able to detect drift for the input data. There are different types of data. These are tabular or columnar data, images, time series, and text data. And then your inputs could be categorical or continuous features. And then your model could also be doing a classification type of a model or a regression type of a model. And then, so when for drift analysis, you do need a training data, because that's what we are going to use for baselining. When the training data is provided, so you basically derive the schema. Schema is essentially, if it's a tabular data, you derive what are the different features, and then what are the for each feature, whether it's categorical or continuous. And then we also measure some statistical metrics on the data, like mean, standard deviation, and etc. So this is what we would use to compare against the data at the prediction time, right? And then there are different algorithms to measure the drift detection. There are several open source algorithms like Kolmogorov, Smirnov, Wasserstein distance, Shabisha. There are quite a few of them. DKube supports about 7 of those algorithms. And then you would also want the ability to bring in your own custom algorithm in addition to the standard algorithms that the platform would support. Right? In terms of prediction data, so now you have the training data, you could do the baselining, you have some understanding of what the training data would look like. Now you're comparing against the prediction data, and prediction data, if the deployment is KSER, KSER has something called cloud events. It's a particular format in which it logs the inputs and outputs from the model. You need to be able to grab that information, and also if it's a custom deployment, so they may provide the inputs to the model in a tabular format, like in a CSV file, or if the model is somewhere else on the SageMaker, SageMaker has a particular way of logging called SageMaker logs. One needs to be able to interpret those. Right, and then given the prediction data, now you have the trained data, you compute the statistical distributions. You would also want to compute the drift on each feature, in addition to calculating drift on the complete data set. And finally, when you have the ground truth, we will be able to calculate the actual metrics like your accuracy, your mean square error, and all of those. And you would want to be able to plot them on a time scale. So this needs to be done on a continuous basis, right? Like periodically, whatever maybe the time, could be every day, or could be every week. So you could have your drift. You may want to calculate your drift probably every week, but you may not have the label data every week. You may have it like every other week. So they need to run at different intervals. And then, so the people actually deploying the model may not know which metrics to alert on. So this information may have to come from the data scientist, like, okay, no, so these are all the metrics that I want to watch on, and these are the like a soft threshold and a hard threshold. If it breaches any of my thresholds, I want to be alerted, either through an email, or you can basically notify it on the UI. Right? And then a centralized UI where you want to be able to visualize the statistical metrics over a period of time. You should be able to go back at any time and see why, what happened, why the drift occurred, and what caused the drift. And then you would want to drill down to how a particular feature is drifting over a period of time. So this is from a drift calculation point of view. What are all the features that a product needs to support? And then, as I was mentioning before, there is some work in the community today. If you look at KSAR, there is one drift detection example. It uses alibi detection. And then the KSAR also has one example for explainability, but that's very tied to how KSAR implements deployments. But I think the product, the model monitoring product by itself needs to decouple from a particular type of deployment. It needs to work with any deployment. And then at a high level, the architecture, so you have at the bottom, you have your training pipeline. So getting the training data, and then it's computing these artifacts, training artifacts and model artifacts. By model artifacts, I meant, remember we talked about the thresholds that the data scientist needs to provide, and also the model itself. And then the model gets deployed in KSAR. So you have the live data coming. And then based on the live data, so KSAR logs the data through these cloud events. And then so they get fed to this block on the top, which is a model monitoring. It does data drift given the two data sets. And then once you have the ground truth, it can calculate better metrics. And then what I didn't talk about is the deployment health itself, which DKube implements. Like, so it basically gets the health metrics, like the latency, utilization, CPU memory utilization, those kind of metrics periodically, and then you can also do some alerting based on that. Right? And then zooming into this block, the model monitoring block, the way we are proposing is that, so you have a API server, so which your UI and SDK would interface with. And then it uses a MySQL database for storing your configuration. And then it talks to Argo based on your configuration, talks to Argo, and then launches the workflows. You need a watcher to monitor how the workflows are running, if they're successful or not. So you may want to reflect the events on the UI, so they get notified. These workflows themselves, they take inputs from your training data. It could be coming from Feast, or it could be any other data source. And then prediction data coming from KSAR, this is just an example. And then your label data, it takes them as input, and then it produces an output. So the metrics, these are the drift metrics that get stored in Prometheus. And then there are certain other artifacts. So these are like your distributions, your KD graphs, kernel density graphs, or it could be logs. They could either go to Minio or they could go to NFS. And then so you have UI on the top, which is basically interacting with the API server and also basically reading metrics directly from Prometheus for graphical purposes. So this is architecture, and then so these are some screens from DKube. So this is the bottom here. What you're seeing is basically a drift page. where you can see that this is an insurance example. You have drift on age, sex, BMI. You can see the distributions, the training data distribution and prediction data distribution. And we are changing the way it renders from this representation to this on the top, which is a kernel density graph. We are overlapping both training and prediction data. So this one is for the continuous data. This is for the categorical data. And then on the right bottom, what you see is the images. So it's an X-ray example. What you're seeing here is for visual, in the case of image, there is no real feature as such that user can understand. That when we say there is a drift on this particular pixel, they may not, doesn't make any sense. So what we're doing is we are running SVD on both the training and prediction data, singular value decomposition, and then we get the eigen phase or the representative image from both the data sets and then showing it for visual purposes, in addition to calculating the actual drift. On the top here, you would see that, okay, there are different charts that you can plot. So this one is a prediction request versus alerts. The alerts are based on the thresholds. Okay. With that, if I have time, I'll give you a live demo. So let me, I have 5 minutes. Let me share. I'll connect to VPN. 3 types of resources at the very, these are like building blocks. We have code, data sets, and models. Data sets and models are version. So you can attach any data set to any workflow, either it gets mounted or some reference is given about the data set. And data sets is a way to represent your training data, your prediction data. That's what we're going to use. And then we have the IDEs and VS Code, Jupyter Lab, and all of that. And then the model monitor is on deployment. So I have here 2 model monitors. One is an image data set. The other one is an insurance data set. So if I click on it and then I go to drift, it gives you, so these colors here, those are like green, yellow, whether the monitor is healthy, or its warning is basically a breach of your soft threshold. So this one gives you the data drift. Let me show you the. It looks like my thing is not running here, but at any given time, you could basically go there and you can see the drift. This one has some, let me log out and log in again. Yeah, okay. So there's the image data set. As you can see, at any given time, you can go back to any time in the past. You can see that there is a drift, and then this is the drift trend. You can also look at the performance. So this one is, you can see these different metrics that you can plot. Again, these dots are like a soft threshold and a hard threshold. You can go back to the insurance MM. So you can see the distribution of data, and then you can see whether there is a drift or not. So that basically ends my presentation. Thank you. Any questions?
Is there any questions we could answer? Now that we have back online, I think Jeremy had a question. Subra, can you still hear us?
Hello, I can't hear you.
Jeremy, you want to ask your question again?
Can you hear me now?
Yeah, I can hear you now.
Yeah, so I was curious for the model monitoring implementation, were you collaborating with Selden or some of the other communities in that, or was the implementation specific to DLCube?
Yeah, it's specific to DKube. Yeah, so yeah.